the structural insulated panel building system in LaHouse.
LaHouse Resource Center is a showcase of solutions for producing high-performance homes for our hot, humid climate and natural hazards, all based on results of building science research. It demonstrates a range of proven ways to gain so many benefits to enjoy every day and to have more control over our lives. Think about it. As we shape our homes, we shape our future.
One of the 4 high-performance building systems demonstrated in the construction of LaHouse is a structural insulated panel system, or a SIPS building system, used to build the east section of LaHouse containing the dining room and the kitchen. SIPS panels are factory-made with polystyrene foam sandwiched between wood OSB skins, creating strong building components that provide structure and insulation in one, without the conventional framing with studs and rafters. The panels range from 4 by 8 feet to 8 by 24 feet in size with various thicknesses, and can be pre-cut in the factory with window and door openings to fit the home plan, if desired. Either way, construction is fast, needs less labor, and a lot less construction waste to the landfill. SIPS creates a very energy-efficient building shell, much like a foam cooler for cold drinks. No stud framing means truly continuous insulation without gaps, voids, or compression. And SIPS buildings tend to be exceptionally tight, minimizing energy-wasting air leaks. Since termites can eat OSB and like to create superhighway tunnels through standard foam, LaHouse used SIPS with borate-treated foam and OSB to prevent costly hidden termite damage. The SIPS in LaHouse are also fortified with hurricane connectors to meet the design criteria of a high-wind hurricane zone. In part 2 of this video, you'll see how the SIPS in LaHouse was assembled from start to finish and why. LaHouse Structural Insulated Panel Building System Part 2, from the ground up. A T-shaped adhesive sill gasket was installed along the edge of the slab under the bottom plate with several purposes. Number 1, it seals the gap under the bottom plate to stop a major source of air leakage. Number 2, it stops moisture that wicks up concrete from wetting the wood. This is known as a capillary break. And number 3, it provides a built-in flashing to protect the panel and the bottom plate. For high wind resistance, a double bottom plate system was bolted to the slab at 18-inch intervals. One was inset in the SIPS panel and glued to a wider bottom plate. This made it possible to add metal plate connectors to better secure the SIPS to the bottom plates that are anchored to the foundation. The screen mesh is a stainless steel termite barrier to prevent hidden pathways. 4-inch thick panels of full wall height were set in place, and the seams were spliced together with manufactured splines resembling narrow, thinner SIPS strips. These splines provided a means to secure and seal the seams while maintaining continuity of insulation in the seams. Although the R14 insulation value is lower than the R19 used in the stud-framed walls in LaHouse, the whole wall performance of the SIPS is better because the insulation is continuous throughout, and it is airtight. To allow for on-site flexibility in building LaHouse, the SIPS panels were ordered to fit wall and roof heights, and the openings were easily cut on site. To provide structural support for the installation of windows and door units, foam was routed out along the cutout edges, making space to insert lumber to line the openings. To complete the building enclosure, LaHouse used 8-inch thick R30 panels, 2 alternative ways for demonstration purposes. Long panels with 2x8 rafter insets to splice the seams were raised with a crane and attached to form the roof. This creates a pre-insulated roof and an unvented attic system. Unvented, semi-conditioned attics are an easy way to keep the air conditioner and the ductwork within the conditioned space, eliminating the typically huge energy losses from ducts in hot, vented attics. This saves energy directly every day and reduces the cooling load, so a smaller, less expensive air conditioner is needed. If the roof design makes it difficult or expensive to use SIPS for the roof, they can be used as the ceiling instead, creating an airtight, fully insulated, walkable attic floor. This method was used over the home office and is visible through a SIPS knee wall at the end of the exhibit room. When SIPS form the ceiling, it is best to avoid cutting holes for light fixtures or other purposes. That would substantially reduce the energy-saving advantage of the SIPS system at a crucial location, where air leaks and heat transfer can have major impacts on home performance. So LaHouse exhibits a simple but elegant built-out kitchen lighting solution that avoids recessed fixtures. Long, specialized SIPS fasteners were used to tie the roof or ceiling panels to the walls at close intervals for wind uplift resistance. The lumber splines at 4-foot intervals were also secured with hurricane straps. SIPS panels are manufactured with preformed channels for running electrical wiring. Spaces are routed out for outlet and switch boxes wherever needed. Plumbing is best routed in interior wall framing whenever possible. When needed at an exterior wall, such as at the LaHouse kitchen, furring strips were installed to make space for piping between the panels and the drywall. Because SIPS are made of OSB and foam, it is especially important to protect the panels from water and moisture intrusion, since they don't have the same drying capacity as a wood stud building system. So LaHouse used robust window flashing systems that protect the sills and corners with sloped drainage channels. The walls were wrapped with very tear-resistant non-perforated house wrap with a low water vapor permeability rating, and seams were taped. The roof panels are protected with adhesive membrane roofing underlayment. With SIPS, windows and doors are the only insulation gaps. LaHouse has all insulated doors and windows that meet Energy Star label criteria for the Deep South, Climate Zone 2. The side doors are fiberglass skin insulated doors with low-E insulated glass. The windows have clear low-E glass with a very low solar heat gain coefficient to greatly reduce summer heat gain. In the kitchen, the windows have durable, efficient fiberglass frames and are protected from windborne debris with economical accordion shutters. The home office windows have treated wood frames for decay and termite resistance. The front window is protected with decorative hinged board and batten hurricane impact shutters. A few points to consider. SIPS homes typically cost 1 to 3% more than standard framing for custom home designs, but production builders can optimize labor and time savings to offset the higher material cost. Since there is always a learning curve in new methods, training and experience are important to ensure the most cost-effective results. An advantage of SIPS is that it results in an energy-efficient, airtight building with much less effort and attention to detailed workmanship. Yet, as with any high-performance home, it is important to build tight but ventilate right. So LaHouse has not only right-sized efficient cooling and heating systems, but also ducted, filtered fresh air ventilation with damper flow controllers to get clean, controlled fresh air and a supplemental energy-efficient dehumidifier to maintain comfortable, healthy, relative humidity below 50% regardless of whether or not any cooling is needed. Lessons learned in building LaHouse SIPS section include: high wind connection methods are different for SIPS. Load calculations and specifications should be clearly determined before finalizing the designs and beginning the construction. Even if the construction crew is trained, other trades, such as electricians and plumbers, may be unfamiliar with how to efficiently install their systems in SIPS. Time, labor, construction waste, and material errors can be further reduced when construction plans are provided to the SIPS manufacturer to pre-cut all the openings. In summary, SIPS create a strong and highly energy-efficient building with less reliance on detailed workmanship to achieve a tight building. Experienced SIPS builders and designers are less plentiful, but the technology is mature and has been well researched and verified. You're invited to explore LaHouse inside and out, its cutaways, feature signage, models, publications, library, and the website, and to learn about how you can shape your future with a high-performance home.